A2 Maths Integration. Okay, so what I'd like you to do is just have a go at differentiating e to the kx. Hopefully without your notes, hopefully you can do that yourself, but just have a go. What does e to the kx go to? Okay, so hopefully you thought about using chain rule. If you differentiate kx, you get just k, so you can bring the k to the front, e to the kx, or maybe you just remember that as a general result. So well done if you managed to get ke to the kx, which is a result we've proved before. What we're looking at now though is integration, and as you know, integration is the opposite to differentiation. So if I've differentiated this function to get to that gradient function, if I want to go back, then I'd have to use integration, and that allows us to figure out how we go about integrating exponential functions. If we differentiate and we multiply by k, then when we integrate, what we need to do is divide by k. So in this case, because we differentiate, we integrate, we can divide by the coefficient of x, the number in front of x. Then we get e to the kx is going to be 1 over k e to the kx plus c. So just make a note of that in your notebook under the title integration. Okay, so and pause before I move on. Okay, so the same idea again. Have a go at differentiating ln x. And as I previously said, I hope you're trying to remember it rather than just diving straight for your notebooks. And if you remember how to do it, it was the function that we rearranged to write x equals e to the y. Okay, so what do we find that result to be? It was 1 over x. That result you must learn off by heart. But this is quite an important result because it means that if I want to integrate 1 over x, which previously was the only one I couldn't do, because you could write that as, let me just get my pen out, you could write this as x to the minus 1, but if you were asked to integrate that, like we would have done previously, when you tried to use the standard rules, you increase the power by 1, which goes to 0, and then you got something like this, x to the 0 over 0. And so obviously in that situation you can't do it. That's a completely meaningless statement because you can't divide by 0. So we couldn't previously do x to the minus 1. Anything else as a power was fine. Doesn't matter what else we put up there, we could have integrated it. But we were never able to integrate x to the minus 1. That is until now. Now that we know that the differentiation of ln x goes to 1 over x, it means that the integration of x to the minus 1 goes back to ln x, or the natural logarithm of x. Okay, so what I'd like you to do, grab your notebooks, just write that down. Integration of the function 1 over x is going to go to ln x plus your constant of integration. It's a backward step from being able to differentiate ln x, means you can integrate to get back. So pause if necessary while you get down the notes you need. Let's try the same for sine kx. So you've got the same idea now. You can almost do this the same as the previous one. How do we differentiate this? We can use chain rule, so we're timesing it by k, and we're changing sine to cos because sine goes up positive, so it's positive gradient straight away. What do you do when you integrate then? Well, because I times when I differentiate, I divide when I integrate. That's why that k seems to disappear, because it goes to 1. So the sine when you integrate goes to cos, but notice that when we differentiate sine, it's positive cos. So when we integrate cos, it stays at positive sine. You need to be very wary that you don't fall into the trap of thinking cos goes to minus sine. It doesn't. Okay, so cos kx goes to 1 over k sine kx plus your constant of integration. All right, being very careful. It's the opposite way around. Sine differentiates to cos, so cos must integrate back to positive sine. Okay, pause if necessary again. Okay, so let's have a look at cos kx then. Well, we know that when we differentiate this, yes, the k is going to come to the front, but also that cos goes to minus sine. That's because it starts up there at 1 and straight away its gradient goes down. So it's minus sine. So if I wanted to integrate that, what's going to happen is, yes, I'm going to divide by k to get rid of the k, but I'm also going to have to take the negative sign again to make it go back to positive. So that's where the change of sign comes in when you're integrating the sine function. Okay, now that's the opposite to when you differentiate. You differentiate the sine function, it stays at positive, but when you integrate the sine function, it goes to negative. So remember, it's the opposite way around to differentiation. So sine kx will go to minus 1 over k cos kx plus c. And does that make sense when you differentiate it? Yes, because cos changes the sign to minus, so therefore you get back to plus. Okay, right. Get the rule down before we move on in your notebooks. And let's have a quick go at some of these then. So pause when necessary until you've had a go yourself. Right, so the integration of 8e to the 2x. So pause there, have a go yourself. Okay, so hopefully you said, I got 2x, I can forget the 8. The 8 could go outside the integral, it doesn't really make any difference. What do I do when I integrate? I divide by 2 as opposed to timesing by 2. Well, 8 divided by 2 gets me 4. Don't forget the plus c. Right, 6 minus 4 over x. Well, the 6, when you integrate, that's okay. Don't forget you haven't got a times sign there. Right, it's a minus sign, so these are separate functions. So concentrate on the 6 first. I integrate 6, I get 6x. I integrate minus 4 lots of 1 over x. What might not be a bad idea is to think of it like that. So minus 4 lots of 1 over x. That's what you're doing. Okay, so minus 4 of that. And the reason why you might write it like that is because then you say, oh no, how to integrate this bit. The integration of 1 over x is going to go to ln x. So that's where that ln x part comes just there. Okay, right, try this one. The integration of 2 sine x minus cos 4x. And don't forget, before you pause it, don't forget that you can do this as 2 separate bits. So integrate that minus the integration of this. Okay, so let's see how far you got then. So the integration of 2 sine x, well, sine normally differentiates to cos. So if I differentiate in sine, it goes to positive cos. So if I'm integrating, it does the opposite. That's going to go to minus cos. The 2 stays at the front, so it's minus 2 cos x. Cos 4x, well, cos would differentiate to minus, but integrate, it stays the same. So that minus sign will stay there. So what do I get? Well, I get minus 2 cos x minus, because there's no change in this bit, a quarter, because that 4 is coming on to divide, sine 4x plus c. Okay, and thinking about going backwards, cos changes the sign from minus back to plus, whereas sine leaves it alone when you differentiate, hence why it's still minus there. Right, try that one. Okay, so pause if necessary. Okay, so hopefully remember your rules from last year. Nothing's changed. You integrate this, increase the power by 1, divide by that new power. So I'll get 5x to the 5 over 5, but the 5's will cancel out, leaving me just x to the 5. This one, the minus 3, if I'm integrating it, get divided. So it goes to minus 4 over 3, e to the minus 3. So there we go. And you can always check by going backwards. 5x to the 4, yes, differentiate that. Minus 3 comes down to the front, so the minus to the minus makes a plus. Divide by 3 and times by 3, yes, that's where the 4 comes from. Plus c. Okay, so last one. Minus 1 over 2x. All right, pause it there. Okay, so this is why I gave you this hint earlier on up here, because it's quite likely you might have done something like ln of 2x or something along those lines. But what you've got to remember is really 1 over 2x. A way of writing that could be writing it like this. 1 over 2 times by 1 over x. Now if I think of it like that, 1 times 1 is 1, 2 times x is 2x. It's the same as that. Now, if I write it like this, what that means is I could take the half outside, because that is just a number. I'm allowed to take that out, and I can ignore that 2 there completely. Why does that help me? Because then I've got 1 over x is ln x. So really, what do I end up with? My result, a half from the front, ln x plus c. So very well done if you manage to get those. What I'd like you to do is just practice some of those with these 2 just here. Don't just dive for your calculators. I know your calculators can work it out, and I don't mind you using your calculators afterwards to check your results, but just make sure you're capable of doing them without your calculators as well, just in case the examiner chucks in something like a bit of algebra, or your calculator doesn't leave it in exact form. Okay, so pause if necessary, and then we'll have a look through these three questions. Okay, so this first one, hopefully when you integrated it, that's what you should do first. You integrated e to the 2x and you got e to the 2x over 2. You integrated minus 2 and got minus 2x. Once you're at that stage, you can substitute these numbers in. So you substitute in e to the 6 over 2 minus 6. Take away e to the 4 over 2 minus, that's a plus 4. So we got down to this answer just here. And then once you've done that, there's your exact answer. And you'll notice your calculator probably wouldn't leave it in this exact form, but you've got to leave it in that exact form just there. You lose quite a few marks if you just use your calculator. Okay, right, try this one. All right, let's think what to do. Okay, so pause if you want to. Right, so the first one, similar to what we just talked about, the 2 over 3 bring out. So I can think of that as 2 over 3 ln x. It's 2 over 3 times by 1 over x, so it's 2/3 ln x when I integrate. This one though, don't be tricked out, is 1/5 x to the minus 2. So I could write this as a 5th x to the minus 2. And how do I deal with minus 2? I increase the power by 1, which goes to minus 1, divide by that new power. So that's where these 2 answers come from. Okay, so just double check. Right, so what next? Substitute the number 2 in, substitute the 1 in. That's what I've done there. And because it wants it left in exact form, don't work out these ln functions apart from that one, because ln 1 is just 0. So this one's going to go to 2/3 ln 2, leave it as it is. This one's going to go to 1 over 10 minus 1 over 10, but I'm adding 1 over 5 here, which is where the plus 1 over 10 comes from there. Okay, there's no plus c's because these are definite integrals. You've got a definite answer. Right, so therefore have a go at this one. Find the smallest obtuse angle A given the definite integral, all of this. Okay, so see how you can't just type it in your calculator because they're actually giving you an answer and they want you to solve it. So pause if you want a good chance yourself. Okay, so let's see what you did then. So hopefully you integrated 5x to get 5x squared over 2. Hopefully you integrated this. Let's get our head around what's actually happening here. Well, 2a is just a number. Okay, so is 4ax. What do I do when I integrate sine of 4ax? The 4a is going to come underneath, and so I end up with 2a over 4a. Sine goes to positive cos when you differentiate, so it goes to negative cos when I integrate. So hopefully you've got something like this. There's that first one integrated. Here's a second one because the 2a and the 4a cancel out to make a half. There's that minus sign appearing because sine integrates to cos. And of course, the actual number itself, the 4ax, stays the same like it does with chain rule. Right, so I know that that integral just there equals 10.4. So what I can do is I can work it out the same as I did with these two, and I'm going to get that. Okay, I want to substitute the 2 numbers in. So there's number 2 subbed in. All right, so 2 into there is 4. 4 times 5 over 2, yes, 10. Put 2 into there, that's where the 8a comes from. Put 0 into both of these. That bit's going to collapse straight away. So 0 squared. And put 0 into cos. As we know, the cos function goes up to 1 when you substitute 0 into it. So that's why we've got just minus a half, because cos 0 is 1. Okay, so there we go. I know that equals 10.4. Right, so what can I do? Well, I can do a bit of rearranging, couldn't I? I could take that to that side, I could bring the 10.4 over this side, and I could get cos of 8a equals 0.2. Right, now I can solve it. Solve it as you would do normally. So 8a equals all these different values. I just wrote down all the values I know. and I want to find the smallest obtuse angle. So you've got to think of your radians. The obtuse angles are anything between the acute angles are anything between 0 and 90 degrees. That will be 0 and pi over 2. The obtuse angles are anything between pi over 2, which is 90 degrees, and pi, which is 180. So the first one of these numbers that falls in the pi over 2 to pi region is going to be, once I've found the a value out, is going to be 1.74. All the other values are either acute or reflex, or maybe another obtuse just in there as well. Okay, that's the smallest obtuse angle though. So well done if you worked through that. It's quite a tough question. What I'd like you to do is just have a look at solving this one. So again, have a go yourselves, pause it, have a good think about it, see if you can solve that problem yourself. Okay, so we know that we can use integration as a tool for finding area under a curve. Okay, so if I'm looking at a shape like this, I've got to try to picture how do I work out the area of this shape when I know how to work out the area under a curve, not the area between two curves. So the way I'm going to do it is this. If I work out everything under e to the x, in other words, I work out that area just there, and then I take away the part I don't want, which is the area under there, I'm left with this shaded area here. So I'll show you what I mean. So the first thing I'm going to do is work out that full area under e to the x. And if I do that, I integrate between 0 and 1. I know the integration of e to the x is just e to the x because that does not change under differentiation or integration. They're exactly the same function. So e to the x between 1 and 0 is just going to get me e to the 1 minus 1, and that's good enough. Okay. Right. What about the area under sine x though? So I look at that and I think, well, that's going to be integration of sine x between 0 and 1. So I can substitute those. I'll work out the integration of sine x first of all. And I know that sine x goes to minus cos x because it's the opposite to differentiation. Substitute the 1 in, substitute the 0 in, just making sure that cos 1 gets us 1. Sorry, cos 0 gets us 1, and cos 1 I can just write in an exact form as cos 1. Right, so how do I work out the shaded area, which is that blue section just there? What do? I'm going to have to take that answer, sorry, that one, away from that one just there. It is the difference between the two sections. So this shaded area here is going to equal e to the x minus the area under y equals sine x. So I've got e to the 1 minus 1 minus 1 minus cos 1. And that's going to go down to that answer. Get used to leaving things in exact form unless they state otherwise. But it's highly likely they want it in exact form because they're testing your ability not just to use a calculator. If you did have to do it to a certain amount of decimal places or significant figures, 3 significant figures minimum, unless stated in the question. Okay, it may be more stated in the question, but if you go below 3, there's a good chance you're going to make a rounding error. There's a good chance you'll lose marks. So anybody that wrote 1.3 would lose marks. Okay, so plenty of work to be getting on with because you've got integration of e's, sines, coses, and integration of 1 over x's. But you've also got some questions where you're using that to solve problems like area and things like that. So take your time, work through each of these exercises. Don't be lazy. Make sure you're practicing some of those hard ones as well.